Hello everyone. I'm going to run real quick through your second identity, trig identity, called the Pythagorean identity. And if you recall, your first one was simply tangent of theta. Oh, why isn't it not writing? Tangent of theta is equal to sine of theta over cosine of theta. So that was your first one. So your second one is going to be based upon the Pythagorean theorem. And it's going to be a squared plus b squared is equal to c squared, given a right triangle. So remember that from your middle school in geometry course. And we're going to do the exact same thing, because if we were to drop an altitude here and we created a right triangle, we would still have that a squared plus b squared equals c squared situation. Now in this case, r is equal to 1, so we would have a squared plus b squared is equal to 1 squared in our unit circle situation. But this is going to apply don't matter how we dilate this circle, and we will have any radius. It's going to work for any radius. Because one thing that was probably not discussed in your geometry classes is that all triangles are what we call cyclic polygons. And I wish we would cover circles very early in the course instead of toward the end of it in geometry. But triangles are cyclic polygons, and they have some really cool properties. What that means is I can take a circle and inscribe it or circumscribe it around this figure here. And that does some really cool things. But another thing that it does, and you may remember this from geometry as well, is midsegments. Well, if this is circumscribed in a right triangle, your hypotenuse is the diameter. And if I were to take the midpoint of the diameter, these would now be radii, two radiuses. So that would be a radius and that would be a radius. This would be an r and this would be an r. And because trigonometry is based upon angle-angle similarity, given reflexive property right here, and given parallel lines, because these are midsegments, these would also be corresponding angles, and those would be congruent. These two triangles, this one right here and the big one, are similar, and they're going to have the same trig ratios. So it's really, really cool on how circles come into play. And again, trigonometry functions are known as circular functions for good reason. So what we're going to do is we're going to have our a squared plus b squared is equal to c squared right here, given this right triangle. And this a is nothing more than your delta x right here, which turns out to be 1/2. So that's going to be like 1/2. And your delta y, this b, is root 3 over 2. And we're using this example right here. We're just picking this triangle right here. All right? So what we're going to do is we're going to have a squared plus b squared is equal to c squared. This c should equal to a 1. So let's go ahead and test it out. And remember from a previous lesson, this is your sine, this is your cosine. So we're going to test out the identity sine squared theta plus cosine squared theta is equal to 1. Second identity. Now when we prove identities, we leave one side alone and play with the other. Doesn't matter which one you pick. I could try and turn this into that, but it's going to be much easier to work with this and see if we can get a 1 here. So my sine is 1/2, so I'm going to do 1/2 squared, and I'm going to do root 3 over 2 squared is equal to 1 squared. Okay? Oops, I should have had a 1 squared there. Okay? And that's going to be 1/4. Now root 3 over 2 times root 3 over 2, when you square the root 3, that's a 3. When you square the 2, that's a 4. So that's going to be 3 over 4. That's going to be a plus is equal to 4 over 4, which is equal to 1. And 1 squared is equal to 1. So that checks. It works for any of these. I could go down here and do the same thing, and obviously when I square, that's going to be positive, that's going to be positive. I'm going to end up with the same thing. I could pick this one right here, and again I'm going to have the same thing. Root 2 over 2 squared plus root 2 over 2 squared should equal to 1 squared, or just 1. Well, of course, negative times a negative is a positive, so that can be 2 over 4 plus 2 over 4 is equal to 4 over 4, which is equal to 1. So the identity works. So again, your Pythagorean identity is sine squared theta plus cosine squared theta is equal to 1. And I can change this dilation on however I want. It's still going to work out just fine. Alrighty, so I'm going to go ahead and get this posted and get on to trig of any angle.